Hi everyone, I'm Sarah, and I will be presenting on the defense mechanism of the Bombardier beetle. So just a little background information about these guys. You can find them anywhere on Earth except for Antarctica, and on these 6 continents that you can find them on, you can mostly find them residing in woodsy, foresty areas where they can take shelter under leaves or in the crevices of trees. They're also a part of a very large family extending to about over 500 different species, with each of an average size length of about 1.2 to 1.8 centimeters long. So for size comparison, your fingernail is about that same length of these beetles. So these guys aren't really that big whatsoever. Also, just a little fun fact about these beetles is that they are, for the most part, considered carnivorous, which means that they do eat other insects. And for farmers, this is great news because it means that they will get rid of all the pests that are eating their crops. And yeah, that's always a good thing for the farmers. So lastly but not least, they are the most famous for their defense mechanism, which I will be talking about next. So what exactly is this defense mechanism? It's known that when threatened, these bombardier beetles actually spray chemicals in a rather violent manner, almost like a mini bomb exploding, toward whatever or whoever is attacking them. More specifically, the chemicals that are mixed together inside the beetle near the anal glands of the beetle are hydrogen peroxide and the hydroquinones. What the effect is of mixing these two together results in an explosive spray of heated water and something called benzoquinone, which can lead to minor burns and blisters in humans. Also, I'd like to say that when I mention or when I describe this chemical, these secretions coming out of the beetle as heated, I don't mean just like, the temperature of hot water that you would find running under a sink. I mean heated chemicals as in they reach up to 100 degrees Celsius. And for those of you that don't know how hot that is, 100 degrees Celsius is the temperature that water boils at. So you definitely do not want to be around one of these guys when they secrete these chemicals / this heated water. So this video I'm about to show you is a video of a researcher poking and prodding at one of these bombardier beetles just to get it to secrete all of its chemicals. In this slow-mo video right here, you can actually see that the beetle is able to redirect where it sprays its chemicals. Right there, you can see that it's mostly directing it toward the tweezers, which in my opinion is one of the coolest things about these beetles, which is that they actually have control of where they can spray these things and accurately, spray all their chemicals, all their defense mechanisms all over their whoever or whatever is attacking them. So, how exactly do these bombardier beetles put this defense mechanism to the test in real life? Well, these two researchers in Japan by the name of Shinji Segura and Takuya Sato collected 2 types of toads, the Japanese common toad that you see on the left and the Japanese steam toad located on the right, as well as different size bombardier beetles in foresty areas of Japan, and they compared, how each toad would react to the chemicals secreted by the beetle. The main differences between the 2 toads is that the Japanese common toad actually shares the same habitat as these bombardier beetles, whereas the steam toad lives in an area just outside of where the Japanese common toad and the bombardier beetles stay. So how they set up this experiment was that they actually took a common toad and a steam toad and they would put them both separately into these 2 different containers, and then they would leave them each with 1 bombardier beetle, which would then be consumed by these toads, and the researchers would observe the toads to make sure or to see if anything would happen after the beetle secreted their chemicals inside of the toad itself. So the results of this study were that 34% of the Japanese common toads vomited or regurgitated the beetles out, whereas 57% of the Japanese steam toads also vomited and regurgitated the beetles. The average time it took for these beetles to actually throw up these beetles range from about 15 minutes to about an hour and a half. And even more surprising is that 100% of these regurgitated beetles actually survived, like as in they survived the partial digestion of the toads. And yeah, I think that's actually, really incredible in my opinion. So this video I'm about to show you is one of the toads from that study that actually regurgitated these beetles. And you'll see that they're covered in all this nasty, oozy enzymes from the toad's stomach, and you will also see that they're very lively, super swarmy, and yeah, just super, super buggy. Let's see, right about now. There it goes, all wriggly, squirming, definitely alive, and covered in all those enzymes. So I just want to note real quick that you can see a considerably large difference between the Japanese common toads that vomited out the beetles versus the Japanese steam toads that vomited out these bombardier beetles. It's about a 20% difference, which is pretty significant. And just as a reminder, the common toads were the toads that shared a similar habitat or shared the exact habitat with these bombardier beetles, as opposed to the steam toads that lived just outside the area of that habitat shared by the beetle and the common toads. So the researchers believed that the reason why the common toads vomited up the beetles less is because of the fact that they probably had more time to adapt to these chemicals released by the beetles because they are around them more often, more so than the steam toads. As a result, the steam toads were not so used to these chemicals being secreted and are more sensitive to the overall effect that the chemicals have inside the toad once they consume these beetles. So overall, is this defense mechanism effective or not for the beetle? I would definitely argue that it is very effective and very useful against other threats that the bombardier beetle may run into. It is also notable, though, that within the research, they did find that larger sized beetles did have better success in escaping from toads that tried to eat them, and they believe that this is because they are able to hold more of these chemicals and therefore release more of these chemicals whenever they feel threatened, which may have to do with upsetting the digestive system of the toad when they are consumed, and therefore causing them to regurgitate or throw them up more. Vice versa, the smaller beetles did not fare so well because they were not able to secrete as many chemicals. So that is it for my presentation. Thank you guys very much for watching.